You know, when I first hear a title like Optomechanical Engineering Technician, I kind of think, well, that sounds pretty technical, but not necessarily like the most glamorous job title. But
Right.
then I really dove into this RoleCatcher guide you sent over, and wow, this job is so much cooler than I ever would thought.
It's funny how some of the most impactful fields are kind of like hidden in plain sight. Like most people don't realize how much of our lives, like our technology, relies on this stuff.
Exactly. And the guide really gets into it like we're talking about building devices that manipulate light. I mean, how wild is that?
It's like stepping into a sci-fi movie, but it's real life.
Totally. And speaking of sci-fi, this guide mentions deformable mirrors
Yeah.
and optical mounts. I mean, what are those things? In like plain English, what are we talking about here?
Okay, so picture this. You've got a super powerful telescope, right?
Hmm.
Way out in space, capturing images of galaxies like millions, billions of light years away.
Okay, I'm picturing it.
So to get those crystal clear images, you need a deformable mirror, which is literally what it sounds like, a mirror that changes its shape to counteract any distortion in the light waves.
So it's like constantly adjusting thousands of times a second.
Exactly. It's incredible technology.
That's wild. And to make sure that mirror can do its thing, you need an optical mount.
Exactly. Think of it like the ultimate stabilizing system, because even the slightest vibration can throw off those delicate components. It's all about precision, right?
Wow. So these technicians are basically working on the tech that allows us to explore the universe in like crazy detail.
And that's not even scratching the surface.
What else is there?
Think like super high-speed laser communication systems, sending data faster than we ever thought possible. Or, those incredible microscopes that let scientists see the tiniest little things with crazy accuracy. It's all connected.
Okay, yeah, my mind is officially blown. But for a second, let's get down to earth, literally. Because the guide does mention building prototypes, running tests, troubleshooting equipment. So, what does a typical day look like, really, for an optomechanical engineering technician?
No, it's definitely a hands-on job. You could be in a clean room 1 minute, like meticulously assembling a deformable mirror, and the next you're in the lab testing and calibrating, these complex optical systems. It's very dynamic.
Okay, so not just sitting at a desk all day, then.
No, not
Oh,
at all.
well.
It's way more dynamic than that. Remember in Apollo 13 when they had to like improvise that filter solution?
Yeah.
It's kind of like that level of ingenuity and problem solving.
That's a great analogy. Speaking of challenges, the guide does mention potential exposure to hazardous materials, which, let's be honest, that's a little different from a paper jam or like, awkward office birthday
Yeah,
parties.
you could say that. I mean, depending on what they're working on, we're talking lasers, chemicals, sometimes even like cryogenic fluids.
So safety is definitely a top priority.
Absolutely, yeah.
It's definitely a career path for someone who, doesn't mind a little controlled danger. So we've talked about the day-to-day, but what about like the bigger picture? Who really thrives in this kind of environment? And maybe more importantly, who might find it a little challenging?
I think, someone who's really detail-oriented, a natural problem solver, someone who really enjoys working with their hands, you know.
Mm-hmm.
If you were that kid who loved taking apart their toys, figuring out how they worked,
Oh, 100%.
this might be the career for you.
And that was me all the way. My parents were thrilled. But seriously, this meticulousness you mentioned, that tracks with what I'm seeing in the guide. Like, it seems like one tiny error could have huge consequences.
Absolutely, yeah. Precision is key. But it's not just about those technical skills. The guide also emphasizes communication, teamwork, because these technicians, they're working closely with engineers, scientists, other technicians. So being able to explain things clearly is crucial.
So it's not just about being like a lone wolf in the lab. You need those people skills too.
Oh, absolutely. You've got to be able to work together effectively.
Okay, this is already painting such a vivid picture of the job. So let's get into like the education and skill section a bit. Because it mentions an associate's degree as a common starting point. But then it also lists these other fields, robotics, material science, even computer science, as being beneficial. And I'm not going to lie, at first glance, those seem a little unrelated. So how do those other areas actually play into this field?
Well, that's where things get really interesting. So an associate's degree gives you a solid foundation, but knowledge from those other disciplines, that's where you can really set yourself apart.
Okay, so like robotics, for instance. I mean, I'm picturing robots, lasers, mirrors. I'm not quite connecting the dots here. Help me out.
Think of it this way. Robotics, it's not just about like building robots, right?
Mhm.
It's about understanding how to make things move with like insane precision,
Okay.
which Obviously, super important when you're talking about these delicate optical devices, right?
Right. Right. Yeah, that makes sense.
Like imagine a surgical robot, you know, performing some incredibly delicate procedure.
Oh, yeah.
It's applying those same principles, just on a much smaller scale.
Okay, that makes a lot more sense now. So what about material science then? What's the connection there?
So think about the conditions that these devices have to operate under, right?
Okay, yeah. Pretty intense stuff.
Exactly. Lasers generate heat. You've got extreme temperatures, constant vibrations. You need to know which materials can handle that, or they'll just fall apart.
Oh, totally. So it's not just a matter of slapping any old mirror into a laser system then?
No, no, not at all. These are not your bathroom vanity mirrors, you know what I mean?
Yeah.
You're talking specialized coatings, different rates of expansion, materials that can withstand incredible stress.
That's a whole science.
Exactly.
Okay, and then there's computer science. I'm guessing that's where the programming side comes in.
You got it. I mean, so much of this is automated these days, right?
Yeah.
You need sophisticated software to control instruments, to collect data, all that. So a strong computer science background, it's definitely an asset.
It's like all these different fields are all coming together in this one job.
That's what makes it so interesting.
I know. Okay, so we've got the education piece. We've talked about those seemingly unrelated fields. What about certifications? Because I saw the guide mention a couple, like COT and CLAD, which, I'll be honest, I have no clue what those even stand for.
Yeah, those are specific to the field for sure.
Can you break those down?
Yeah, so it's COT, that's Certified Optomechanical Technician. It's a way to really show potential employers.
Yeah.
You know what you're doing with.
Okay, yeah, like a stamp of approval.
Exactly. It proves you understand all the core principles, the assembly, the testing protocols.
That's huge. And CLAD, what's that all about?
So that one is Certified Lab UW Associate Developer. And Lab BW, it's basically a software platform that's used in labs all over the place, like controlling instruments, automating experiments, all that good stuff.
So if you're fluent in Lab UW, you're basically like speaking the language of the lab.
Exactly.
These certifications, they sound pretty valuable. Do they really make a difference when you're like applying for jobs?
Oh, for sure. I mean, it shows commitment, right? It shows you're serious about your career
Yeah.
and in a competitive job market.
Mm.
That can make all the difference.
Absolutely. Okay, let's talk career progression a little bit because the guide, it breaks it down into these 4 stages, right? You've got entry level, junior technician, mid-level, and then the senior technician. So starting at like the very beginning, entry level, what does that actually look like?
So at that level, you're really getting your hands dirty, you know, assisting the more senior technicians, building prototypes, just like absorbing all that knowledge.
Like an apprenticeship almost.
Yeah.
And then you move up to junior technician. What changes there?
So as a junior technician, you're taking on more responsibility, right? So fabricating and assembling components, maybe doing some troubleshooting, really starting to hone those skills.
So it's not just following instructions anymore. You're starting to like make your own decisions.
Exactly, yeah.
What about mid-level?
So at the mid-level, you start to see more of those leadership qualities, you know. You're not just doing anymore, you're starting to lead. So collaborating with teams, maybe managing smaller projects, mentoring those junior technicians.
Oh, cool. So you get to be the mentor now, passing down that wisdom. That's awesome. Okay, then, the peak, the senior technician level, what does it take to reach those heights?
At that point, you've got a really holistic understanding of the whole process, you know. You're overseeing projects from start to finish. You're giving expert advice. You might even be managing budgets, working with outside vendors.
Wow. So it's a lot more than just the technical skills at that point. You're a leader, you're a mentor.
Exactly, yeah. It all comes together.
The guide actually gives these great little example profiles for each stage, which I thought was really helpful.
Yeah, it helps to put it into perspective.
Like for entry level, they mention a passion for developing cutting-edge devices.
You can really sense that enthusiasm.
And then by the time they reach the senior level, they're talking about like a proven track record of overseeing the development and implementation of complex optomechanical projects.
Yeah, that's a mouthful.
Right. But it shows how much you can grow in this field.
Absolutely. I mean, you can start with that love of tinkering and end up leading these groundbreaking projects.
That's really cool. You know, it really does seem like a career that's challenging, always evolving,
For sure.
and just like incredibly impactful. We've covered so much ground here. But one thing that keeps coming back to me is this whole idea of like the human element, you know?
Oh, absolutely. And the guide focuses a lot on the technical stuff, which is obviously important. But those softer skills like communication, teamwork, problem solving, they're just as crucial.
Totally. And I've seen it happen, you know? Like, you can have a team full of brilliant minds, but if they can't communicate effectively, forget it.
Oh, yeah. It's a recipe for disaster.
Exactly. Like imagine trying to walk someone through like a complicated assembly process, but your instructions are like totally unclear. Or you're trying to troubleshoot some technical glitch, but everyone's so busy like trying to prove their own idea is the right one that no one's actually listening to each other.
It happens all the time. And it can bring everything to a screeching halt.
Ugh, I can picture it now.
So for anyone listening who's thinking, okay, this all sounds amazing, but how do I actually get better at those softer skills? Like how do you build those collaboration muscles?
That's $1 million question, right? And it's not enough to just like know that teamwork is important. You have to practice it.
So how do you do that?
Seek out opportunities to collaborate, even if it's just on small projects, you know?
Right.
Practice explaining technical stuff clearly, like maybe try explaining it to a friend who has no idea about that field. Right, like if you can't explain it simply, you probably don't understand it well enough yourself.
Exactly. And honestly, sometimes the most important skill is listening.
Oh, 100%.
Really listening to your team, considering their ideas, being open to different approaches, it makes a huge difference.
It's like in this field and just in life, the best stuff happens when people can work together,
Yeah.
right? Share ideas. It's not just about the tech itself, it's about the human connection behind it all.
I love that because, yeah, we've talked a lot about the technical side, and that's obviously important. But when you combine those skills with, like, a collaborative spirit, a passion for the work, that's where the magic happens.
Couldn't have said it better myself. Well, this has been awesome. Thanks for geeking out with me on this one. I learned a ton.
My pleasure. Anytime.